Welcome to Module 2 in the short course. This is our first presentation where we'll look at the theory of production in GTAP. We're building our way up to a general equilibrium setting. That means it's almost impossible for us to put the pieces together without trying to acknowledge which piece we're currently looking at and thinking about how it all fits. And so with that, when we look at something like production, or next week, the next module, when we look into the consumer side, we'll start by looking at an overview, what we call the circular flow, or the sort of full economy. In this online course, we are focused on a domestic economy. So in the circular flow, you see down here the rest of the world, which engages everything on the interior through trade and foreign investment. In GTAP, every region has this same structure internally. This is the domestic economy, and then a bunch of these domestic economies will be linked through the trade relationships with the rest of the world, which is one of our advanced topics that we get to in the second phase of the course. On this interior part, though, let's just acknowledge up here at the top we see something called the regional household. That regional household is something we'll dig through next week in detail, but it's the demand side of the economy, the final demand side. So it sits up here at the top. It earns all the income by selling its factors of production. So the regional household owns the labor, the capital, land, natural resources. Those factors of production are the income generating assets, and they're sold to a set of firms. The regional household is also a demand source. So in addition to having the factor income ownership, they purchase goods and services and make investment or saving decisions. And that takes care of everything. Up here is sort of regional household demand side of the economy. Move all the way down through these arrows and you see the producer block. And that production block is what we want to focus on today. We're going to build up the supply side of the economy, of the domestic economy, and work our way through that. It's one of the simpler topics, but it's a great way for us to get introduced into some of the software, some looks at the data, while also sort of building up our modeling skill and reading the code, understanding how to do analysis. So the producers, or the producer block, is comprised of a set of firms. Those firms can hire the factors of production away from the regional household, so they pay for those and use them to convert to marketable commodities, or things that can be marketed as final demand commodities. They also purchase intermediates from other firms, or if we were doing trade, they can purchase those from the rest of the world, those firms. Those primary factors of production and then the intermediates are what the firms or the producer block combines through technology, right? So they apply their technology capacity and combine those intermediate purchases with the primary factors of production, or sometimes we call that the value added, and then they make those into goods and services that can be sold either as intermediates to other firms or as final demand goods. And those could be purchased in final demand, either on the private side of the regional household or the government side. And so that's the one final piece we'll look at here. This green block is where private households make purchase decisions as part of the regional household, and the government makes purchases as part of the regional household. So we're going to leave that demand side behind and think about this producing sector that makes the goods that can be sold into final demand, but also can be a demander itself. You see here there's an arrow pointing from the producer block back to itself, indicating that firms buy the output of other firms to use in production. Okay, breaking out that producer block, we get something that we would call the tree structure of the firm or of a sector, or in GTAP specifically, we call it an activity. Okay, so if we look at this from the top down, again, this is a single um, generic firm, right? They all have sort of the same tree structure pulled out of this producer block. At the top, we have output QO. These are lowercase variables, right? So when we write something in lowercase in GTAP, that means we are considering it to be a variable, and not just a variable, but a percentage change variable. So we start at the top here with the output determination, QO, the output for the sector or for the activity. And if we move down, we see that there are these two branches. One is the QINT, or the intermediate input, and it's an aggregate itself, or a composite itself. And on this side we have the value added input. Okay, and so output is made by combining value added, a composite, intermediates, a composite. If we move on down on this leg of the tree, or on this branch, I guess would be the right term, of the tree, we see that we have 1, 2, 3, 4 different primary factors. So labor, capital, land, natural resources, and they take this percentage change variable QFE. Okay, so QFE would be the individual demand, or the percentage change in the demand for land in this instance, or for capital. Okay, and so these demands, or these quantities demanded, are required to make what we had up here, which was the quantity value added composite input. The same thing is going on this side of the production tree. We have the quantity of intermediates, and down here we have the quantity of individual commodities, right? And again, all of these lowercase q's are quantity variables, and they are percentage change. So if we moved all the way to the bottom, you see two more, QFD, QFM. Those are outside of our scope right now, but it is certainly the case that you can get the domestic version of some intermediate good that you're using in production, or you can get the import version. And of course, the import, going further on, could be from any number of regions. Okay, so really the theory of the supply side, or the production in GTAP, is what we call nested production, or sometimes it's called multi-stage optimization. So we haven't quite got to the optimization part, but the firm produces output, and just think of it as a bunch of as a production line. So at one stage of production, the final output is made by combining two things: this composite input that was made somewhere else on a different production function of all the primary factors, or the value added. On the other side of the firm, you're making something called an intermediate input, right? A composite intermediate input. So this is an aggregate made up of all the individual intermediates that can be used in production. This is a composite input made up of all the primary factors that could be used. Okay, and so there's those two interact, or aggregate, or go through the technology right here, represented as CES, constant elasticity of substitution. And so this diamond here is telling us that there's a technology aggregator, or production technology in place that works over value added composite and intermediate composite, and it's actually got a governing parameter, the ESUBT, or the top level substitution elasticity. Okay, so if this top block makes one production function, then someone has to have a production function, or somewhere a production function has to be in play that makes this value-added composite, because we don't. It's not something that that exists, right? It's a stage in the production, and so this is its own production block, right? So the making of the value-added aggregate is also a CES aggregator or CES production function with a governing substitution elasticity right here, ESUB VA, or the value-added substitution elasticity. Move to the other side and we get our block for intermediate production. Again, a composite sits at the top to be used in the top level, but beneath it there must be a production technology in place that combines all the potential intermediates for this specific firm or this specific activity, and that again is a CES in this diamond. And here we have the governing parameter, commodity substitution elasticity. Okay, so it's how these things get combined to make the intermediate. Okay, so if we were to trace this firm or activity, and you see these A's used as subscripts all the way through, that indicates that we're in a single sector, right? And this is sector A, right? And so it could be motor vehicles, it could be coarse grains, right? And so whichever one we're in, the structure looks the same. What's going to be different is potentially the controlling substitution elasticity, the CES which is part of the CES technology, but also the cost structure, the importance of these different factors of production in actually generating this, right? And so while the structure looks the same, the factors of production will have different importance in the initial data. That mean the cost shares will be different, which means the responsiveness across sectors is different. And so if we have one objective in terms of analysis in this entire module, it's to sort of understand the differences in sectors and the commonality in sectors. So we have this, GTAP, like most large-scale models, has to have several sort of template setups, and this is the template for production by firms or activities. I use those terms interchangeably in the code. You'll see that it's always A or ACTS, ACTS, for the sets, but in words we typically call it firm or the firm, sometimes the sector. But so in that regard, our nested production function, it is CES technology. We're imposing weak separability, and this is useful for us, and depending on your micro theory and how much of it you remember, you know that there are any number of conditions that have to be met to get a valid regular cost function for a firm. And those conditions largely depend on the substitution possibilities between all of the inputs. Well, when we impose weak separability and the CES function, we reduce the amount of unknown parameters that we have to make. And so that's more of an advanced topic that we'll try to talk about a little later. But in terms of what we want to think about, it is weak separability. So the production of composites at any level imposes this separability, meaning that you've just reduced, if you're in one branch of the production tree, the value-added branch, all of those goods in the intermediate are going to have a limited impact into how we think about this, the value-added side. And in fact, the only way they impact it is through the overall top level of the production tree. So if the average price of intermediates change against the average price of value added, then we'll either expand or lower our dependence on value added. But there's no such thing in this weak separability that we've set up where the mix of capital and labor in the value added aggregate is directly impacted by the price of fertilizer over in the intermediates, or the price of fuel in the intermediates. Now, that could be viewed as very limiting for some applications, and in fact, as you move through this course, one of the things we'll want to think about is revisiting this nested CES production structure, or at least the template form of it that's set up in GTAP version 7, and how we might need to change that for some different activities. Specifically, the potential to substitute energy and capital is one of the more prominent models we have, and that's the GTAP-E version of the model, or the GTAP energy policy version. So the notes here just indicate that the value-added aggregate input for a given firm will be independent of the price of any individual intermediates, the composition, meaning the mix of land, labor, capital, natural resources. Same thing goes in the reverse direction. The composition of the intermediate aggregate, so the use of chemicals, of fertilizer, of plastics, of I'm already running out of things to think about, fuel, coarse grains, all the sort of goods that are there to be used as intermediates. That mix that goes into making the intermediate aggregate, or the composite intermediate, will be independent of the price of any individual primary factor. Okay, so that means that there are no price ratios in play, and that limits the substitution possibilities. It means, in effect, that every intermediate will have the same substitution possibilities with any individual value-added input. Okay, so there's only one factor in play, and the same goes in the other direction as well. So it's a symmetric, symmetry is obeyed in this model. So we should just indicate then, but the quantity demanded of the value-added aggregate will of course depend on the relative prices of those two aggregates. And so the implication would be that if the price of intermediates, or let's say the price of value-added, labor or capital, or both, start to fall, then the price of value-added falls, and that means the price index at the top level for value added must be falling, or is likely falling if those are large shares in the total cost. And so it would be the case that we would see intermediate use fall in response to this lowering of prices on the other side. But they should all fall proportionally. They should all fall through the average price, not through the individual prices that are in the model. Okay, we've already said this a few times, but in terms of output determination, so you solve the production tree going down, but we need to know the output level, and it certainly is the case that we have an equilibrium governing the model between supply and demand that is going to tell us the output level, but it's also appropriate to think about the equilibrium condition finding the price, right? So the fact that we have to sell everything that's made, and we have to make enough for everything that is purchased on the demand side, means that there's an equilibrium condition which finds the price that will cause those equilibrium conditions, or those quantity conditions, to balance out. And so we might think about output determination really being determined by cost minimization on the firm side. Firms are using a homogeneous technology, the CES. We are using a homogeneous CES that will employ constant returns to scale, and then that means that the level of output will need to be determined in this cost minimization problem using a zero profits condition. Okay, and so if you have constant returns to scale, we have sort of this atomistic perfect competition going on the firm side. So even though we have the sector represented, the idea is that there are a bunch of replicated, individual firms within the sector, or within the representative firm, and then the zero profits condition can be the governing factor that determines output level. So the market equilibrium determines the price that sets the average cost for all the inputs. So zero profits in this case means that there are no excess profits to the firm. There's nothing left to as sort of bonus remuneration, it all can be accounted for in either the primary factor or the payments to primary factors or the purchase of intermediate inputs. So firms are produce at their average cost. The market determines the price that will achieve equilibrium. That then gets set as the unit cost, and firms will exhaust that price received on inputs. And then, if we've already mentioned, the CES technology is employed at every level of the production tree. And so we have CES in 3 different places, as we've talked about, and that nesting of the CES yields some conditions that we'll have to think about later on when we get into some advanced ideas about parameterizing a model. Okay, just to sort of reiterate or review or summarize, I want to be thinking about, as we move on into operationalizing this and we begin to read through the GTAP code, because this is, as we mentioned in the previous module, very experiential. We want to be examining the GTAP code, the model as it's written down. We want to be finding pieces of data that live in the GTAP database, and then we want to be running simulations to try to uncover the relationships. And so if we go a little light or fast through the theory, relying on sort of our microeconomics and try to pull it apart, that has shown to be a good way for us to learn this in context of the full system, because any general equilibrium has to be broken into its components for us to operationalize all these different things. And so again, the firm that we have, or an activity or a sector, a representative firm, whatever you want to think about it as, we call it, tend to be firm in the model. A firm makes one output typically. The GTAP model will certainly accommodate making more than one output, a multi-product firm, and there are definitely analyses that require that, or that would make us want to do that. But in this case, let's think about it as a single product firm, and it is a series of CES production functions to get that final output that is made. So at the top level, optimally combine value-added intermediate aggregates or composites, and by optimally we mean minimize the cost. At the second level of this multi-stage optimization, we have the value-added nest and intermediate nest. They are at the same level, and those are both optimal or minimum cost ventures. So the same behavior or the same assumptions are inherited as we move down the production tree. So we optimally or minimally cost combination of value-added inputs to get the value-added aggregate on that side of the nest, and on the other nest we have intermediates where we optimally combine intermediate inputs, minimizing their costs subject to the target level of the intermediate aggregate. Okay, because we don't want to skirt completely over what's going on with the CES, or mostly because I want you to be sure you have the notes somewhere in your GTAP materials, this is how the CES production function looks. So that when I'm saying minimize cost or optimally combine, this is what we're saying. So QI here is an input, so we've any input. So this is a more generic production function than we've employed. So we choose the level of QI, so this is a factor demand, such that we would minimize cost, where costs are the sum over all potential inputs, price of inputs times the quantity of the input. And then for cost minimization, the constraint is that you stay on the technology frontier. Okay, so the aggregate output, or the quantity of output, is determined by some summation over the quantity choices of inputs, with a negative rho being the exponent. And then we have this beta I, which is something like the share parameter. Okay, so it's a scaling parameter, if you will, Out here we have -1 over rho, and that's the CES. Okay, that's what the CES production technology looks like. The value of rho would tell you what elasticity you're working with. Okay, so these are like the production elasticities, and then if you combine them, you'll get the CES substitution elasticity. If you have the CES substitution elasticity, you can convert it to a more conventional elasticity like you might find estimated in the literature. And so your reading in this module actually gives you some notes to think about in terms of Allen partial elasticities of substitution and how those relate to CES elasticities. If you were going to optimize that, you would just write the Lagrangian. So we got the cost objective here, the constraint over here. We would need to write the set of first order conditions with respect to all of the choice variables, QI, all those inputs, and to our Lagrangian multiplier. Okay, we're going to stop our talk on production theory there. That's about as far as we want to go. We will make our way through the theory as we keep working. We'll expand on what is here a little bit, but we really want to talk about it in an operational sense. And our next lecture is going to be about how to operationalize something like that nested CES production function in the GTAP model. So we're going to get into the code. And so rather than write out the solution for this CES Lagrangian, you're certainly welcome to work it out. We're going to move straight to the factor demands when we get to the next lecture and talk about how they look in GTAP. It turns out the CES is pretty nice to work with, even though it in its levels form here it looks a little bit like a task. It turns out it simplifies pretty nicely in percentage change form. So once we log differentiate this or linearize these factor demands that would be the solution to this, it makes for a really nice analytical tool, and it's why the CES is still so popular. It's easy to implement and easy to understand the analysis from. Okay, that concludes our theory of production lecture. You'll have a review quiz that you can look at, and of course, if you have any questions, please get to the course contact information and use email. You can also use the discussion forums specific to this module.